All right, everyone, welcome out. This is our final session for the summer on Introduction to R for Data Science. And today we're going to be talking about R notebooks, which I think is a vastly underutilized resource. So today is less about how you program with R, how you make it do certain things, and more how to make what you do look nice. Especially, this is really good for giving stuff to your advisor, to your collaborator, or just keeping a nice, almost lab notebook style record of what you've been doing, which is very important for reproducibility. Now, before we get into that, I do want to go over the homework from last time. We had some homework on ggplot in order to practice our plotting. So I've got those homework problems here. Let me paste the Gapminder link into the chat. So Gapminder data can be found here. So in case you don't have it, you can go ahead and download it because we'll be using that today. So for the homework, this first one is using the Gapminder data set and things we've covered in the webinar. We want to show the average income, so GDP per capita, of Asia changed from 1970 to 2005. Plotting it using both a smooth curved and individual points or scatter plot on the same graph. So there's several different steps we have to do in here. So first of all, of course, I have to set my working directory. So I'm just working on the desktop. And then we need to read in our data. We use read.csv, Gapminder data.csv. Run that. Oops, and I forgot to save it. There we go. Gapminder equals read.csv. There we go. We can do that. We can even look at the summary of our Gapminder. And we've got a few different things here. We've got about 1,700 records, looks like. We can say all our years go from 1952 to 2007, so we're going to need to cut those down. We know just from seeing it, otherwise there's a bunch of countries in there that we don't want because we just want the Asia ones. So next thing I'm going to do, some comments. Next thing is filter data. So I'm going to call this, let's call this Asia, as a subset of Gapminder. And we need to filter this down. There's actually 3 different filters we need to do here. We want only Asia, and we want stuff between 1970 and 2005, which is 2 different filters. I will see. So let's start with Asia first. So Gapminder $continent equals Asia. Run that. And if we do a summary of Asia now, we can look at it. We can see that now we're down to only about 400 countries, still have everything else basically the same. So now we're going to refilter that again. So Asia is a subset, not of Gapminder, because we don't want to go back to the original. We want to keep slicing down what we have until it's what we want. So now we're subsetting Asia, and Asia $year is greater than or equal to 1970. Then I'm going to copy and paste this because the next one is pretty similar. I'll subset where it's less than or equal to 2005. Now there is a way to combine all 3 of these subsets into a single statement. I'm not doing that here because we didn't cover it in class, but there's a way to do that. As you get more into R, you'll learn about combining these Boolean expressions. Anyway, so if we run all of these, and now look at our summary of Asia. We're down to just 231 records. We've got our years are from 1972 to 2002, so that's right. Continent. Let's check our continents. So this is not a function we've used, but you might find it handy. Unique of Asia continent. This will tell us all the unique values of that. And it's just one, just Asia. So we have subsetted down to Asia. We've got our years right. So now we've got the data we want. Now it's time to actually plot it. So plot it using both the smooth curve and individual points on the same graph. So to plot it. So first, of course, we need to load our library. Otherwise, R is really going to complain at us because it won't know how to find ggplot. So our base function, if you remember, is ggplot. And we need to give it two things. We need to give it the data itself, and then we need to give it the mapping so it knows what to do with that data. So the data in this case is Asia, and the mapping is AES. Remember, that's aesthetics. So we're plotting the, let's see, GDP per capita over time. So that makes sense that X is going to be year, and Y is going to be, I can never spell this right, so I'm just going to copy it, GDP per cap. All right, and so we can run that just to make sure it doesn't crash. Oops, like it just did because I forgot to actually run loading the library. There we go. So this is basically just make sure it doesn't crash. We get out our plot. It has our year and our GDP per cap, but there's no data on it, obviously. So now we need to add our plots. So we want a smooth graph and we want individual points. So we covered individual points in class last time. So that's geom point. Geoms, remember, are the different styles of plotting your data. So if we add a geom point, we get the individual points here. So these are all the individual data points, but we also want a smooth line. And this was not covered in class, that I remember anyway. And this was specifically to try to make you look up how to do this, as were the two bonus exercises. And that's because what we could cover in ggplot in the lessons last week and what you'll want to do are two very different things. There's going to be a lot more stuff out there. And so I want you to start getting in the habit of being able to find your own answers of how do I do this in ggplot. So the function we want for the smooth curve is geom smooth. It's you can look it up on that cheat sheet I sent out last week. If we run this, oh, but you have to spell geom right. Run that. This is just telling us some of the details of the smoothing. Don't worry about it. Now we have our individual points and we have our smooth curve down here at the bottom so that we've got our graphic that we wanted. Are there any questions on this? I know I'm going kind of fast. Please let me know if there's any questions or anything that's unclear. Okay, I'm going to take that as a no. All right, now bonus challenge. So using smooth curves, like we did in the previous one, plot how the average income has changed for each continent over the same time period. That is one plot that shows 5 curves, make each continent a separate color. All right, so we need to do a few things here. We need all the continents, but we need the same time frame. So I'm going to copy and paste some of this data, some of this stuff up here, because no sense in reinventing the wheel. If you've already written code that is similar to what you're going to do, go ahead and reuse it. So we're going to just do, we'll call this one continents. Continents. Well, the first one, we are not subsetting the actual continent to Asia, so I'll just get rid of that line. We'll call this one continents. Is a subset of, go back to the original data, Gapminder year greater than or equal to 1970. And then we substitute in continents here, because again, we're slicing it further down. So then we're going to subset it down to less than or equal to 2005. So run those. Check it quick with summary continents. Make sure it's what we think. About 900 things. Got 1972 to 2002. Okay, looks good. All right, now we need to plot it. So again, let's go with our, again, use your code. So we've got continents here we want. So we're plotting continents. We still want year and GDP per capita, so that's fine. We do not want the point. We do want smooth. So let's run this and see how it goes. Okay, so progress. We now have the global smooth line, but we don't yet have one for each different continent. For that, we have to give ggplot some sort of clue as to how we want to separate this out. And what I'm going to do, since we already know we're going to have to make each one a separate color, I'm going to go ahead and just add color. Color equals continent. So it says we want things to be colored differently based on the continent. And that may be enough to do it. And this, there we go. Because it has to separate out, give each continent a separate color, it makes each one a separate line. And we see the 5 continents here, we automatically get our legend over here, and we're able to see how they've been changing over time. So that's how you plot this on one graph. Then challenge 2, use facet wrap to break this above into 5 separate subplots, one for each continent. So this was again to make you look up how to use something online. We're going to start with the same plot we had and just tweak it a little bit, because we already know this base one is what we want. So, and we know from this we need to use facet wrap. Facet wrap is a function that lets you show different subplots in one plot. If we run it just as it is, it's going to throw an error because we haven't told it how to separate out our different subplots. I think there's a few different ways of doing this, but the one that's usually easiest uses R's formula specification, which if you haven't used a lot of other R, don't worry about it. If you have, this will just look familiar. The way to do that is use the tilde. That means by. So we're going to break it up by something. We want to break it up by continent. And if we run that, there we have it. We've got our plots. We've got one separate line for each continent. Each continent is in a separate color, and each continent is also on its own separate little subplot. And this is something that could be very useful in many people's research, where they've got different sets of data that are similar, and they want to show them next to each other in something like this. So again, these exercises were meant to not only use what we've covered, but also force you to go beyond what we've covered to start learning how to increase your own toolbox of what you have available. So, questions on the homework? Okay, I'll assume there's no questions on the homework then. I'm going to go ahead and restart R. I was having some memory issues last time, so I want to make sure I've got fresh memory. Now, on to notebooks. So, like I said, this is how you make your R code really nice for giving to others or for keeping as essentially a lab notebook of your R work. So the way we do this, you have to make a notebook, which is not the same as just a basic script as we've been doing. For this, we're going to make a file, new file, R notebook. It's going to come up, and it has a few different things here. This default layout, or this default template, actually has various things to help explain it. We're not going to worry about it too much. It will be a good reminder when you do it yourself. But there are 3 things that we're going to talk about in more detail in a minute about this notebook. There's 3 sections. The first is this header, which has essentially metadata on your notebook. What the title is, who made it, when it was made. There are various things you can stick up here. There are plain text sections here. So these areas that have the white background, this is normal text. This is meant to be read by a human, not by a computer. And then we have these code chunks. So they have this sort of darker gray background, and they've got these 3 little backticks here, which backticks are not used anywhere outside of computer programming, as far as I know. They're only used by programmers. And the backtick is that little like apostrophe looking thing underneath the tilde on your keyboard. So if you go next to your number keys, left of the 1, there's a little key that has a tilde on top and this little apostrophe looking thing underneath. That apostrophe thing is a backtick. And so there are 3 of them right here. And the stuff in between these 3 ticks is a code chunk. And that is R code meant to be interpreted as by the R interpreter, like all the code we've been writing for now. Now, I'm going to talk more about each of these in just a moment, but I want to show you why this is important. I'm going to save this. And there's a very important thing that happens upon saving. So I'm going to save it on the desktop, demo notebook. So I'll save it as .rmd. Actually, I'll let it put the file extension on. All right, so it put RMD, that's an R markdown document. Markdown I'm going to talk about in a moment. It's a way of formatting things. But the important thing is that that actually created two files on my desktop. There is the demo notebook.rmd right here that I'm actually working in. And then there's this demo notebook.nb.html. I did not tell it to create this. This is a part of what automatically happens when you save an R notebook. And if we open this up, this is what that notebook looks like once it's rendered. So here we've got title, this is the plain text I mentioned, these are the code chunks. And you can tell this is a lot prettier and easier to read than my R code. It's like, this is doable, but if you wanted to add something to someone, especially someone who is not a programmer, this is much easier. This is just a website, and this is portable, something you can give to other people. So this is one of the major powers of these notebooks, is that it makes you a nice report that you can give out to other people and share. Now, before we get into details, I want you guys to do an exercise, which is to make an R notebook, save it, and verify that you got the HTML version. And when you've done that, type done into the chat. I see 8 people. I think there's only 8 or 9 learners in this session. So there's one person still catching up. I'll give you another like 15 seconds, and then we'll move on. Okay. Don't worry, Kate. It was fine. All right. So now I'm going to talk about these 3 different sections. So this first part, like I said, is the header. This gives metadata on your document. We're not going to mess with this very much. You can look up guides as to the stuff you can put here. Main things, there are some basic data on it, and then there's some formatting options. The title here is basic data. It just says title. This is our notebook. I'm going to change this to Jason's demo notebook. And then I'm also going to add one here as the author, Jason G. Wallace. So, and then the output is an HTML notebook. There are various options you can do here to make it fancier or to use different outputs. But we're not going to mess with that right now. Right now, we're just going to keep a very basic HTML notebook. So that's it. And instead of like saving and jumping over, I'm mostly going to be using the preview button here. So I hit preview, and this will render that HTML as I would see it. Takes a few seconds. Here we go. So now you can see the title has changed. It has my name here, and then the other stuff is all going on underneath the hood. So close that. Now, that's the header. That's all we're going to do with the header right now. Now we're getting to this plain text section. So I'm going to go ahead and delete what they have here previously, because we're going to go on our own thing. So the plain text is rendered as Markdown. If you've ever used GitHub or various forums, like I think maybe, probably not Discord, but pretty sure Reddit also uses Markdown. Markdown is basically a simplified formatting language. It's not even a language. It's like just formatting symbols. It helps you make things look nice with just a few quick symbols. So we're going to follow those right now. First is headers. So headers are formed with hashtags. So the more hashtags, the deeper the header is. So the further down it is and the smaller it is. So your first level header has just 1 hashtag. Second one has, this is a second level header, has 2. Third level header has 3, etc., etc. And if I hit preview, we will see that those headers render and that each one is a slightly different size as it's going down, down, down. So that's how you can help organize your stuff. And with some of the fancier layouts, you can actually have automatically generated tables of contents that you can click on that will take you to different sections. We're not going to cover that this session. That's a little too advanced, but it is something that you can do. Now, formatting main text. So there's various types of formatting that you want to put in your text. We're going to start off actually with the bulleted list. Bulleted lists start with an asterisk, like this. First section of a bulleted list. Now, this will not actually work as you think it should. For one thing, you notice how most of these I've hit return twice. That's because when rendering Markdown, 2 returns is the symbol for new paragraph. I only did 1 here, and that will actually cause a problem. If I hit it here and run it, then because it's only 1 return instead of 2, it actually thinks it's part of the same text. And so it just wraps it on. It does not make a bulleted list. However, if I put 2 returns, then it will render it properly as the first section of a bulleted list. And then from then on, like it understands if the line starts with an asterisk, oh, that's just the next section of a bulleted list. So we keep going. And we're going to use this to do our formatting. So bold is formed with 2 asterisks. Any text that is between 2 asterisks is bold. Italics is between 2 underlines. Superscript is between 2 carets. We got subscript is between 2 tildes. And code case is between 2 backticks. You probably haven't heard of code case before. That's okay. Make sure that's all. Yeah, that's all of them. All the basic ones anyway. So let's preview this. And you can see here we have each one of those. So we've got our bold, italics, superscript, subscript, and then code case basically makes it look like computer code. Like it looks like this code we've been writing over here in R, where it's monospace, it's got a little box around it that you might be able to see. And so that's how you can separate things out that are like R commands. These commands are not run. This is not saying this is R code that needs to be run. It's just saying this is a, this looks like code. Like make this look like code. That's all it's saying. And so those are our basic formatting. And then we have numbered list. Start with numbers, obviously. First one, I don't know if this is firmly the rule, but playing around, it seems to be that the first one always has to be 1. That seems like it should make sense, but I'll tell you why that may not in a minute. So it's first item, 2 for the second item, 3 for the third item. We preview that. Oops, and you see I forgot to do that double return, and so it did not separate those out like it was supposed to. There we go. So first item, second item, third item, we have a numbered list here instead of a bulleted list. Now I said that the first one has to be 1. You think that would be obvious, and the next is 2, and the next is 3. That's actually not the case. The first one must be 1, as far as I can tell, but the other ones can be any number. We can make this 9999, maybe any positive number. 457. Let's play around here. Let's try 0. Let's try -5. I don't actually know what these will do, so let's find out. We preview those. All right, so it seems that all of these numbers except for -5, so the negative numbers don't work, but all the other ones work just fine, and you'll notice they don't get translated to what they were. It's not 1, 9999, 457, 0. It's 1, 2, 3, 4. It tells, as long as the number says this is still part of the numbered list, and then it automatically takes care of which number to put there. And so the way that's probably the easiest to do this is, instead of doing random numbers like I did here, you just make everything 1. And the reason you might want to do this is because as you're doing it, you don't have to keep track of which one each of them is. If it comes back and you say, oh, you know, I don't want this anymore, I'm just going to delete that third item, you don't have to renumber things. Things just get renumbered all on their own. And so by just using 1 over and over and over again, you can just make sure that things stay in the right order. You don't have to. Obviously, you can do any positive number, but that's probably going to be the easiest. So just to use 1 saying, hey, this is part of a numbered list. So now we're going to do an exercise. Write something in the markdown section, so the plain text section, using at least 4 of these different formatting things: bulleted list, numbered list, or any one of these 5 ways of formatting. I don't care what it is. You can write about how your day went. You can write a recipe you like. You can just ramble on and write random words. Doesn't matter, but do something that uses at least 5 of these different formats. And I'd recommend at least one of those be a list of some sort, either bulleted or numbered. And then make sure it renders properly. So once you've done that, and once it's actually rendering like you think it should, type done into the chat. All right, so most people done. We'll give another like 15 or 20 seconds. I think actually by that count, everyone's done. All right, thank you everyone. So this is basic formatting. This is the human readable part of these reports. And the things you would do with here is that the markdown sections are used to explain what you're doing. They can be giving the background, they can give the overall aims. Probably you'd start with a header saying, hey, this is the overall aim, this is the experimental design, here's what we did. And then you go into your section and say, hey, here is what each one of these analyses is supposed to do, here's what it means. And so this is, again, the human readable part, the part that's meant to be read by another human being to know what's going on. Now, I'm actually going to delete a lot of these because I don't want to have to keep scrolling down when I show stuff. So, markdown section show what a human should read. These code chunks are for the computer to read, but they're also by default shown to the human so they can see what you did. So as we saw in the preview, we've got this chunk of code down here in the bottom that looks like essentially a copy and paste from an R code. That's exactly what it is. It's showing the code here in this chunk. And so we can use this to execute any R code we want, just as if we were running R. So we're going to load in our gapminder data here. Minder equals read.csv, gapminder data.csv, and we're just going to put the summary of gapminder. Oh, missed the close quote. There we go. Put the summary of gapminder. And so there's two things here. There's both the report and then there's what you're working with. To see it here where you're working, you click run. And normally when you click run, it just runs that line. Now we have a bunch of options. So we can run just that line, or we can run the current chunk, which is this entire box here, or the next one after it. The setup chunk is a special one that comes at the beginning. We're not going to deal with that one. Run all the ones below, run all the ones above. And then biggest one, restart R and run all the chunks. So this is basically from smallest up to largest of how much you're running. These ones down at the bottom, the restart R and run them all, that's what you want to do when you're done. Because these will show, when they display results, they show whatever the last result you generated is. But sometimes you change variables, things change. And so if you were to run that again, it may not be the same. And so a good safety thing is that when you're done, you think you're good, you restart R, you run all the chunks fresh, and you make sure that they still generate what they're supposed to generate. This time, I want to run the current chunk. And so you saw there's a little green bar that popped up over here as I was running, and then here's the output down here below. So here's how we can see the output. And then if we hit preview, that output is also echoed here. So we have the code up here, we have the output from that code down here. And there's a few things we can do with this. So we're not going to go into like much of the actual R code because that was the previous 5 sessions. Now we're going to talk about how to manipulate this. There are some options you can put up here. So when you make a new chunk, let me make a new chunk right here so you can see. I'm going to insert an R chunk. And that will automatically insert one. It puts the 3 backticks. It has little R here in these curly braces that says, evaluate this using the R programming language. As you can see, there are other options up here too. We're going to stick with R. So this is our new code chunk. I'm actually going to, and then with this, we can put things in here. So don't need to, I want to show you how to do that. Let's just delete that. There we go. So code chunk, we put our stuff in it now. Now we can control how much of it the user sees. Because sometimes you want them to see the result, but you don't want them to actually see the code. This could be just for a high-level report to like a stakeholder or to someone who maybe doesn't have the programming background to understand what all the code is. They're just interested in the results, not in which variables you used and which functions and stuff. And so you just want to show them the results. The way to do this is in these curly brackets, you can provide various options. So the one to turn off the printing of the code itself is echo. So echo equals false. That means it will not echo the code to the HTML. And so if I put echo equal false and hit preview, you see the code is now missing. So the code is now being hidden. The flip side of that is results. Results controls whether or not they see what the output is. And the option to turn that off is hide. Results equals hide. If I preview that, now we have the code, but we don't have the results. And if for some reason you want to hide both of them, I don't know why you do this, but just so you know, you just put a comma like you do with functions, and you just add them together. So echo equals false. So results equals hide, echo equals false. Results equals hide means we will not see the results. Echo equals false means we will not see the code. So if we run it, there's nothing there. We're hiding both the code and the results, and so it's not seen. One other useful one here is eval. This is evaluate. If you put eval equals false up here, then it will not run that code, which for most of what you're going to do is not actually all that useful. Usually if you have code, you want it to run. The one time this is really useful is if you're like writing a tutorial for someone. You want to say, this is the code you would use, but you don't want R to actually run it just because it's just a demo. So that comes up every now and then. But we're not going to worry about that. We're going to take those options off. And yeah, so we're going to do with that there. We're going to leave this code chunk as is. We're going to put a new chunk down here for some plots. So I'm going to insert an R chunk. And now that I've got multiple chunks, it's actually useful to be able to keep track of which one is which. So I'm going to give these names. So I'm going to call this one the plot chunk. And we call this one the summary chunk. You can call them pretty much anything. Just if you write a name here right after the R, so R space some valid R variable name, that becomes the name of this chunk. And that's useful because when the R is compiling this into the HTML, sometimes you have problems, like your code has a bug or something just goes wrong, and it uses these names in the error code to let you know where the problem is. You can imagine if you've got like 20 different of these chunks in a long report, and you get an error says that unnamed chunk 18 has a problem, it's going to take you a while to track down what that is. So naming your chunks like this is just good programming practice. It helps keep them straight. All right, I'm going to make this one down here for plot. I'm trying to figure out how much we're going to put on here at once before I do an exercise. Yeah, let's go ahead. I'll do this last thing. We're going to do our gapminder data. Just do a quick one. ggplot of gapminder x equals year. Whoop, sorry. Mapping equals AS. X equals year. Y equals GDP per cap. Plus, well, let's do scatter points. Geom point. So if I run this line or run the chunk, same thing. Oh, can't find ggplot, right, because I forgot to load the library. So as you get more into this, like loading ggplot2 is probably something that would belong in a setup chunk rather than here in a chunk I might be running lots of times. Not going to worry about it right now. So here we've got our graphic, got it fine. We preview. We have our first chunk and its results, our second chunk and its results. So the main thing you probably want to adjust with the figures is their size. So let's put a header here about adjusting figure size. And just to save space, I'm going to put up here that results equals hide so that we don't have a lot of space taken up by this stuff. All right, so we have our plot chunk. We've got our graphic, but I want to change the figure size so that it doesn't take up as much space. So I'm going to have fig.width equals, let's say 8 wide, because I can be fine wide, but I want it to be not very tall. height equals 2. So what this does is these are in inches. How big are any figures from this chunk going to be? So I'm going to run the selected chunk. That does not look as big as it's supposed to be. Let's go ahead and preview it and see. That does not look like it's 8 wide and, oh, wait. I've got an error up here, unexpected symbol in chunk results. I think I forgot to put commas here. Let's try this again. Okay, so no errors making it this time. Let's run that chunk, see if we get a result back. There we go. So, sorry, I forgot to put the comma after the name. So now you can see it's generated the plot. The plot is wide, but not very tall. And again, if we do the preview, that will be echoed off onto the screen. Essentially, this will take whatever your most recent results are here in your actual code notebook and just copy them over here. So it doesn't actually rerun the code to generate this figure. It just takes the figure that's over here and puts it into the HTML document. So now it's exercise time. What I want you to do is I want you to make a code chunk that plots the gapminder data. Let's see here. Let's do life expectancy. Plots gapminder life expectancy versus time using a smooth curve, and then adjust the figure to be 6 inches tall and 4 inches wide. All right, so go ahead and do that. And when you have, please type done into the chat. I can tell just by the time taken it's being a little bit more challenging, which is good because it means making you work. You remember things better that you have to work at. All right, is there anything that people are getting stuck on? That sounds like a no. For the sake of time, I'm gonna give everyone 1 more minute, and then we're going to go ahead and move on so we can close up. All right. So if you were not able to finish, I suggest you revisit this in your own time. This is an important skill because this is what you would do in an actual analysis. You say, hey, this is what I want to show. How do I go about doing it? So to do this, we need a new code chunk. So let's make a new R code chunk. We've got our gapminder data already loaded. So we're going to plot it. So we're in ggplot. Got our gapminder data, our mapping equals AES. See, we've got life expectancy versus time. So let's put time on the x-axis here. Y equals, I can't remember what life expectancy is. Here we are. Life exp. Copy that. And if you remember from the homework, geom smooth is the smooth thing. So that will render it. And we can get that right this way just by running the code chunk. So there's our smooth curve, but we want to adjust the figure size. So we want to be fig.width is, see, 4 inches wide, and fig.height is 6 inches tall. And there may be options somewhere to change this to the default to centimeters instead of inches, but for now we're just going to use the default of its inches. I'm going to run the current chunk again. So now we've got a smaller figure. And let's go ahead and preview that to see how it renders into HTML. A header, figure, and here's our exercise. And we have a 4 inches wide by 6 inches tall figure. And so this is useful because you can, this allows you to tweak and test your figures and get them all looking really nice just by based on the figure size and then doing all the ggplot stuff that we've been doing. So questions on this so far? Any questions on making code chunks, on using Markdown, on using these notebooks at all? Okay, so the last thing I want to show is kind of some bonus material. We're not going to do an exercise on this, but I want you to know what the other options are available. So what we've been doing is previewing this in HTML, or just like actually just previewing it, period, but it would be what it would look like in HTML. Remember where if we save this, every time we save it, or I guess as we preview maybe, it makes that HTML document. But there are other options available. I mentioned in an email that if you wanted to do PDF, you need to install a few other things. The reason we're not making that a strict part is because sometimes installing those dependencies is a little tricky. I know I had some people that had issues getting them all installed. But once you get them installed, if you want to make a PDF, you can access it the same way you get the little preview here. But we hit the little arrow next to it. And you see these various different things here. We've got a knit to HTML, knit to PDF, knit to Word. Knit to HTML is basically what automatically happens every time we save. We click it, whoop, it did something up here. I changed my header a little bit. Don't worry about this, that's automatic. And I click knit, it'll just make an HTML just like we've already done. So no worries there. But we can also knit to PDF. That will run it. Hopefully everything works right. I installed it, it should work fine. Okay, so here we have this. It should be previewing, and then if I go to my desktop, there should have been a PDF show up here, but I'm not seeing it. Knit to PDF, come on. There we go. So you can see it's running various stuff here. The thing with the knit is that it does actually rerun all your code chunks. So that if there's any errors or stuff, it will prevent the knit from happening. There doesn't appear to be one. I don't know why it didn't run the first time, but you can see it's doing a bunch of stuff in the background. And now it is loading up my nice, pretty PDF document here that has, let me zoom, get out of the way. I need to adjust these things. There we go. So you have a nice, pretty PDF document that's pre-formatted with basic stuff. It even has code coloring, which is nice. Our figures, everything else. So there we go. And that should now, here we are, demo notebook.pdf. Okay. And although it's not very common, if you want, you can even knit, no, stop, to a Word document. So knit. Come on. I think I had it doing a PDF. So stop that. Knit to Word. Knit that. So now it should be generating. Again, this will take a few seconds because it has to go and rerun all the code, make sure everything is up and doing what it's supposed to. And now we have, you look down here, output created, demo notebook.docx. Go back to my desktop. Come on. We have, it's somewhere here, demo notebook.docx right there. It's automatically opening up in Word. And so here you have a Word document that has everything with basic pre-formatting, our code chunks, our figures, our outputs, etc. And so these are various options you have for outputting. By and large, HTML is probably what you want because the others enforce page breaks that may break apart things you don't want breaking apart. There's no page breaks in an HTML document. So the default there is probably what you want most of the time, but these other options do exist. So That, and you notice that as I chose each one of these, it added some more stuff up here to the header. Don't worry about that. That's automatic stuff that RStudio is doing for you, so you don't have to worry about it. It's just basic documents. If you do want to get fancier, you would start adjusting some of these things so as to adjust what the output looked like in various ways. We're not going to cover that. It's a little more advanced than I want to get into right now. Suffice to say, there are a lot of ways you can tweak things. When I send out the email this week, I'm going to send out an example of one of the fancier outputs that I happen to really like because it's very good at having a lot of information in a very navigable form. This is our notebooks. They are vastly underutilized, even as I say, even by me, especially by me. I do not use these things nearly as often as I should because they help. They're essentially a lab notebook. You can use this as a lab notebook, going down, making new code chunks, trying new things, trying new notebooks, and then you export them to HTML or PDF. You have a record of what you were doing at that time. And if you write it well and explain things, you have a very clear record of what you did and what everything means. And this is really the core of reproducible science, is making it so people understand what you did, and they understand why it worked or why it didn't work, and what your results are. So that's why these things are important. And I highly encourage you to use these in your analyses. And like I said, these are also great for making reports for like your advisors or your collaborators. It's much nicer to give them a nice, clean PDF document than a bunch of R code that they may or may not even know what to do with. So that is today's lesson. And that is really our entire workshop for this summer, all 6 lessons. So time is yours for questions. Does anyone have any questions on what we covered today or on anything we've actually covered this entire workshop? Floor is yours, open time.
Well, Jason, I think this is a great series of lessons, and I learned a lot. And I think you're right. We all need to use it in our real, in our real projects. But this is really useful, and I appreciate your, providing all these lessons to us.
Oh, you're welcome. Thank you. All right. Well, I'm going to stop recording.